Hello, hi everyone. So welcome back to my channel and let's start with today's Leetcode challenge, that is maximum width ramp. Till now we have completed two challenges, and in case you have missed any, you can watch it on my YouTube channel. I have created a playlist for that. Also, I have created a playlist for Leetcode 75 where I will be solving all the 75 questions that are important for the interview purpose. So you can watch it on my YouTube channel also. So we have this question: a ramp is an integer array nums is a pair ij for which I less than j and nums of I is less than equal to j. The width of such a ramp is j minus I. We are given an integer array nums and we have to return the maximum width of the ramp in nums. If there is no ramp in nums, we have to return 0. We have this example and we have the answer as 4. So because the maximum width achieved at ij will be, for first index it is 0, for last it is 5, 1 minus 5 is 4. So that is, yeah. So we are good on this understanding the problem statement. Let's just move to the intuition building. So we have this question. So how we are getting the answer? Basically, when you see ramp is basically this type of thing, right? A slant, okay, where this is the low and this is the high. So whenever you see such kind of thing, you have to build your answer. So how it is? So let's just draw a diagram for it. 6 will be, let's just say you have this type of thing, xy axis, and 6 will be somewhere here. Now 0 will be here. So this is here. Now 8 will be like this. Now 2 will be somewhere here. So 2 will be here. Now 1 will be here and 5 will be somewhere here. This is 6, this is 0, this is 8, and this is 2, 1 and 5. Okay, if you see this is not a ramp, right? This can be a ramp and this can be a ramp, okay, or anything that from 0 we can create. Okay, this can be a ramp. So let's just draw with them with other pen. So that this can be a ramp, okay, this. Now this can be a ramp, this 0 to 1 can be a ramp, and 0 to 5 can be a ramp. Okay, if you see the width of this, 0 to 8 width is only 1. Okay, we have to get maximum width, right? So this is our main thing. So if you see this width is 1, from 0 to 2 it is width 2, right? Now 0 to 1, 0 to 1 width is 3, and 0 to 5 width is 4. So what is our answer? 4, right? So this we need to get. So yeah, this is a understanding of the problem statement and how we can approach. So if for the brute force approach, yeah, so whenever you get in an interview, you start with the brute force, right? So for brute force, generally whenever you ask questions related to IJ and you need to do some checks and do some operation, you first try using loops. Okay, so what you can do, basically take every ith value this, and for every ith you can check the other values in the array which are strictly greater than, okay, or equal to this ith value, and the index should be greater, right? So whenever for 6 you will check 0, it is not, you will skip it. For 8 you can check, get it, yes it is greater, so you will calculate your answer. Because if you see, you this can also be a ramp, right? Because 6 is less than this, but the width is only 2, right? So you will not get it, right? So for 6 you will get 8, right? So you can get your answer first 2. Now for 6 there is no maximum value, so you will not do it for this. Now you will take value for this 0, because j should be greater, so you will take only values greater than this. Okay, so you can check for all values. 8 is greater, you will have your answer 1. Not greater than this, skip it. For 2, yes, you can use it, but still it is 2. no update. 0 to 1, yes, it is greater, so you will make it to 3. Now 4, 5, 0 to 5 is 4, okay, so you will make it 4. Now move it to next position. Similarly, you will do it for all I pointers where the other value, the jth pointer should be greater than this, okay. So for brute force, you will simply use two for loops for uh, I 0 to n, and for j will be starting from I plus 1 till n, right? And you will basically make your answer here, make your answer using checks, okay. So the check will be simple. If nums of I is less than equals to nums of j, you will update your answer equals to maximum of answer and j minus I, right? So you will take some answer variable that is assigned to 0 currently, okay. Since in the question you are asked if there is no ramp, you can return 0, right? So now for this approach, if you see that I will not be doing complete, so you can understand it. This is a brute force approach. So for time complexity, what will be time complexity? Since we are using for loops nested, the time complexity will be big of n square, and space complexity will be big of 1, okay. So whenever you tell this approach in the interview will surely ask you to improvise on this, because n can be in the range till 10 is to power 5 or 10 is to power 6. So for n square it will be 10 is to power 10 or 12, and that is not an optimal solution. So now interview will surely ask you to improvise on this. Now you try to do a better approach, okay, better approach, okay. So what you need, again you have this array, right? That is 6, 0, 8, 2, 1, 5. If you see, you only need to take those values which are where the first value is smaller and the second value is greater. So what you can do, if you sort this array, right, you can get the non-decreasing order. So that is 0, 1, 2, 5, 6, 8, right? But if you see, whenever you sort the original array, you will not get this the indexes thing, because you need to play with indexes, okay. Maximum width was j minus I. Now since you have sorted it, 0 position earlier was 1, now it is 0, you have lost this index. So what you have to do, you will have to take another array, say s, okay. Now you will store these values with their indexes. So 6 will be stored with 0, 0 will be stored with 1, similarly 8 with 2, 2 with 3, 1 with 4, and 5 with 5, okay. So this is how you will make your array. Now you will sort it. So for with sorting, how it will become, s will become, so 0 will come here, 0 1. Now 1 with 4 index, 2 with 3, 5 with 5, 6 with 0, and 8 with 2, okay. Now what you have to do, since you know that these values are in sorted order, you just have to make your answer your max width, which is j minus I, and j should be greater than I. So while iterating through this sorted array, what you have to do, you need to maintain a minimum, because with that minimum you will get your width, because I should be very much smaller and j should be greater. That's how you will get maximum width, okay. So how you will do it, you have this I will do a small dry run. So you have this 0 with 1, 1 with 4, 2 with 3, 5 with 5, and 6 with 0, 8 with 2, right? You have this. Now you can store this. Okay, you will come to this. You have your minimum will be how you will take the first minimum. So first minimum will be the maximum value, the maximum index you have, you can get. So these are the indexes. Okay, so the maximum index what you can have, it will be size of the array, that is n, where here it is 6. Okay, so we will take it 6. So maximum index will be 6. Now you come to this position, what is the, and your answer will be currently 0. Now you come to here, you will, what you will do, you will update the minimum will be 6 or 1, and answer will be maximum of current answer and the current index minus minimum index, that is 1 minus 1 0, so you will not update it. Now you come to this. Okay, 1 4, you will check what is the minimum of them will be 1 only, and the current index is 4, so 4 minus 1 will be 3, you update it to 3. Now you come to this 2 3, what you will check, 3 is minimum or 1 is minimum, 1 is minimum, right? So you will not update the minimum. Now you check for answer is 3. If you check 3 minus 1 is 2, so you will not update it, right? For 5 sake, for 5 and 5, what you will check, 5 is greater than this, so you will not update the minimum, but for answer you will have to check 5 minus 1, that is 4. 4 is greater, so you will update it to 4. Again you come to here 0, 0 is minimum than this, yes, so you will update the minimum, but then you check 0 is current index and 0 is this, 0 minus 0 is still 0, and the maximum is 4, so you will not update it. Now you come to here 8, so for 2 you will check, yes it is minimum, no it is not minimum than 0, yeah, so you will not update the minimum, but for answer you will check, but if 2 minus 0 is greater than 4, no, so you still have your answer. Now you can return the answer. Okay, and 4 was your answer. If you check in this, 4 was your answer, right? So you can get it. So the pseudocode will be, let's just move to the pseudocode. You can create an array in C++, you can create a vector of pair, or either you can take another vector inside it. Okay, let's just say temporary. Now you will store temporary of ith will be, this will be nums of I and the index for all I 0 to n, right? Now you have your temporary array, you will sort it. Sort temporary dot begin, temporary dot end, right? Now you have sorted, you just have to have one minimum index, that is currently size of the array, that is n, and your answer, that is 0 currently. Now you will go again from I 0 to n, and you will first have your minimum index, that is minimum of minimum index and current index is I, right? And your answer will be maximum of current answer and your minimum I minus minimum index. Okay, so that's how you will get your answer, and after that you will return your answer. So what is the time complexity? This is big of n, this is big of n log n, and this is again big of n. So big of n plus big of n log n plus big of n, which is approximately equal to n log n. Okay, and the space complexity is big of 1, right? Sorry, big of n, because you are using an another array, right? So you have somehow improvised on this, right? You have improvised on this because earlier it was n square, now you have n log n. So this is how you should approach this question, any question in an interview. First you try to do a brute force, okay, brute force approach that you first initially get when you understand the question. Then you try to improvise time complexity, and you can ask your interviewer if you can use auxiliary space that we have used here, big of n, but we have improvised. That is the main thing in a interview. You have to again ask to improvise on this time complexity. Yeah, so whenever you will ask, you will have to improve on this also. So you can ask your whether you have to improve or not. He says yes, so you can try for, since the improvisation of this will be somewhere around big of n, so you can try to improvise. So we will be going that approach now. So the optimal approach, right? Optimal approach, so that will be, if you see that you have this array 6 0, then 8, then 2, then 1, and then 5, and you have to find for each value what is the maximum value on the right side, right? Because for 6 you have to find on its right, if you see this is the right side, and what is the maximum value that you can have which is far than this 6 to get that maximum width. If this 8 was here, let's just say, so what will be that size for so it will be around 6 if it is at this position, because this is 0, this is 6, so the width was 6. So you need to find what is the maximum value on its right side for every value on its right side to have this kind, because this is least, this is max. You have to find maximum value on its right side that is far much than the current value. Because you see for 0 what we have found, this 0 was here, these values are also greater than this, they are far, but they are not farthest, right? To 1 they are not farthest, 5 is the farthest from it, so you have to get this 5 value, right? So how you will get, if you can have this smallest value on the left side and can find the maximum value which is far than this value, current value, you can have your answer. How you can store the least value on its left side, you can to use some data structure. So let's just have one storage, okay, we will check what we have to use, but we can have a storage, right? And then what we'll do, first you will come to 6, okay, 6, there is no smaller value than 6 in this, so you will store it, okay. You have to store this value to get your max least value on its left side. So let's just, what we'll do, we will try to understand if you can break this array into this part, okay, or from here you need to have a minimum value on its left side so that you can get a maximum value on its right side, and that will get you a width, right? The minimum value on its left side is 0, okay, and the maximum value on its right side is 5, so the difference is 4, their position. Now if you check for 6, there is no maximum value on its right side, so you cannot use it, and for 8 similarly you cannot use it since there is no greater value on its right side. So you need to have somewhere smaller value stored somewhere to check if there is any right value on the right side which is greater and is at farthest point. So you can use this storage. First you come to the 6, okay, so you will store the 6. Now you come to 0, you will check if there is any smaller value in it. if it is, then you don't have to use this because you already have encountered a smaller value than this value currently, which will give you our answer. Okay, because if you see, let's just do it. Let's just say you have this 0 here and 6 here, and you initially stored 0. So will 6 make your answer? Let's just say 8 is not here, 8 is here. Okay, so will 0 give your answer better or 6? I think 0, because you need a minimum value on its left side, right? So for in the storage, what will be the check? Either storage is empty, either storage is empty, or the current value in the storage. Okay, current value in storage is greater than coming value. Okay, if the current value is greater, okay, 6 was here, 0 is here. So will 6 make your answer or 0 better? Because 0 is the smallest and any value will be greater than 0 on its right side will better give your answer, or 6, because 6 is far much bigger than 0. So whenever you get a value, either it will be compared to 6 and 0, but 0 will give you better answer, right? Because it is the smallest, you can get easily the value that is greater than 0 on its right side. So you will store 6 here, then you will come to 0. 0 is, since the storage is not empty, you will check if the current value in the storage is greater than, yes, 6 is greater than this, so you will store it the 0. Now you come to 8. 8 is smaller than 0 or greater than, so you not need 8 because 0 will better give your answer. Let's just say 0 is here, 8 is here, and 9 was here. So will 8 will give your answer or 0? Because 8 is also smaller than 9. 8 is smaller than 9. 0 is also smaller than 9. But 0 is 1 point beyond 8. So this width was 3. Okay, 1, 2, 3. But 0 and 9 width is 4. So 0 will give. So we'll store 0. Will not do with 8. Similarly for 2, 1, 5. 0 is the smallest. You have the storage with 0, 6. Now you will iterate from the right side. Okay, and check that current value is greater than the storage value currently. Yes, so now you will check from last. Okay, from last you will check if the current value, so we will rub this thing all, and we will write it again, 6082115. Okay, now from last you will check 5 is greater than 0. Yes, it is. So you will make your answer. So now answer is 5 index is 5 and 0 index, you will store it with index. 0 index is 1. Okay. So 5 minus 1 is 4. You have first got your answer, right? Now you will remove this value. Okay. Because this has made your answer, right? If you check, 1 is also greater than 0, 2 is also greater than 0, but they will not make your answer because you already got your better answer, 4 maximum. So you will remove this because there can be a value in the storage which can make your answer, right? If you say 6 was here, then 1 was here, 0 was here, then 3, then 5, no, then 8, and then your 5, right? Okay, so we will get one more thing. So Right, right. We will get that. So if you say, you will, in this case, if you see, you will have your storage with the value 6, 1 and 0, right? Now when you start from last, this 5 and 0 will check 5 is greater. So what is the index? 5, and this index is 2. 5 minus 2 is 3. So your answer is 3 currently. Now you will remove it. Okay, why I said now you will check. Now you have 1. This is, now you will come to this position, right? And this is 8, right? So you will check if this is, will give your answer. Yeah, sorry for the interruption. Okay, so now what you have done, okay, so you have, when you come to 0, you will check with 5 if it has given your answer, right? Yes, you have your answer as 3. Now you will remove it. Now you will check, because from whenever 0 you will encounter, you will check on its left side if there are some values which can give your better answer with this value, if there any smaller value. So now you come to 1. 1 is smaller than 5, right? So now 1 with 5 will give you answer 4, which is greater than this. So you will encounter with 4. Now you will remove 1, because 1 has already given your answer with the last index. If any value you will encounter on this side with 1, you cannot get your answer maximum, right? You will remove it. So this is why I was telling that you have to remove this value. Now when you come to 6, you will check with 5. No, it is not. Now you come to this value 6 with 8. So what is this value? 6. So the indexing is 0, 1, 2, 3, 4, 5. So 0 with 4, still 4. This is the width. So you will not update it, because you already got 1 and 5 pair with the same width. So you don't need to update it. Now you will come to, you will remove it. Okay. Now you have got your maximum answer. There is no point of going like for each value, because you will not get any maximum width in this size. Okay, because if you start from here, there's some value and there's some value here, you cannot get it. You already got with value this on this index. So this is the approach. If you see, if you start with this again, previous one, so you will encounter with 0 this 5. This 5 is already get your answer, so you will remove it. Now you will check with 6. Well, 6 is greater than 5. Yes, so you don't need to do anything. You will move it to here. 6 is greater than this 1. Don't need to do anything. Come here. 6 is greater than 2. Come here. 6 is smaller than 8, right? Now you have to build your answer. So answer will be, this is 0, this is 2, this is 2. So now how you will get? 2 is a answer that you can have, but already you have 4, so you will not update it. Now again you will remove 6. Now you see, this is the window that you only have. Okay, you already remove 6, and in the size in the array you already have this window. The maximum answer you can get in this window is 2, but you already have maximum answer. You will not do some operation on this, because stack is already empty, the storage. Okay, so since you need what storage, that will be stack, because you need to remove it, and whenever the new value comes, you need to store it in the top. So since stack provides LIFO, that is last in first out, so you will use this. Now you see, the pseudocode will be, you will have stack, okay, of integer type, Now for each value from I 0 to n, what you have to store in this stack? You have to either you have to use this value, okay, or you need to get your answer. You need to have this value also. This was 6 index, 6 value, and you need to play with index. So you can store the index in the stack. Okay, this stack will store the index, right? So whenever you have this index, you can get directly from that array, because array of I is O of one operation, you can get directly. So what you have to do, you check if stack is empty, then you have to store it, or stack dot top will give you that index. So array of stack dot top, what it should be, if you see, this value should be greater than the coming value. If this is greater than this current value, array of I, what you have to do, you have to insert the stack dot push, but you can use only the indexing, so you will push the ith index. Now you have a stack with the index. Since for 6 you have 0, for 1, sorry, for this 0, what is the index? You will have 1, right? And this was your array, 6 0 8, then 2, then 1 and 5, right? So for 6 you have 0, for 0 you have 1. Now for these will not be stored. Now what you have to do, you have to build your answer. So you can have your answer 0, right? And now you will go from right side or from 5. So I will be n minus 1 to 0. And what you have to check? You have to check until these the this ith, this index value is smaller than this. You have to build your answer and remove all the values. So while either you have to check either stack is empty, while stack is not empty. So how you can check? Will not use this operation while stack dot size is greater than 0, while stack is not empty, and stack dot top value, okay, is smaller than current value, that array of ith, and this will also be array of stack dot top. If this is yes, then you can build your answer, maximum of answer and current value. Current index is I, okay, I minus stack dot top is this only. Now you have to remove this, so you will do stack dot pop, because whenever until you remove this, now when you come to this value, let's just say 2, or let's just say 0 again, you cannot have your answer because the stack was empty. So you have to check this, okay. So now you will have to return your answer. So now what is the time complexity that we can get? So this operation is big of n, okay, because we are going from 0 to n. Again, this is 0 to n only, so big of n, right? So the time complexity, if you see, this will be big of n only, and the space complexity will be big of n, since we are using stack, okay. So now just move to the coding part to better understand this approach. So for storage, we need to have stack. Now we have to add all the indexes for calculating our answer into stack. So for int I 0 till, okay, we can store the size in some variable first. Int n is equals to nums dot size, right? 0 to n, we can add all the, do we have to add all? No. So we have to check if stack is empty, or but we have to check either array of, sorry, nums of stack dot top is greater than array of I, right? If this is true, then we have to insert the current index. Okay, what is it? If the current value is smaller than in the storage, then we have to insert it. We have inserted, right? Now we have the storage with all the values in a basically order where stack.top contains the least value. Now you have to iterate from right end to get your maximum width. Now int I will be n minus 1, I is greater than equal to 0, I minus minus. This will iterate from left end, right end, sorry. And now you have to check either stack should not be empty, so stack.size greater than 0, and what is the condition that we have to check? That the current value in the stack is nums at stack.top should be smaller, or it can be equal than nums of I value, right? Because 0 could be smaller or equal to this, then only when we can get our maximum width, because it is provided nums I should be less than equal to j and I should also be less than j, right? So we can get our answer will be maximum. Okay, we have to store it some answer, make it 0, so answer will be maximum of answer and I minus stack dot top. Now you have to remove that value because this has already given your answer, so you will do stack dot pop. So this whole will give your answer, build your answer. Now you just have to return your answer, right? So let's just try to run it on our example test cases. Okay, so it is okay. We have used array nums. Yeah, it is working fine for them. Let's just try to submit it. Yes, we have solved this question. So thanks everyone for watching. In case you do like this video, please do hit that subscribe button, turn on the notifications, that we will be solving all the challenges together, and I will be providing the code for the other two approaches that we have discussed in on our GitHub repo. I will share the link in the description. Yeah, thanks everyone.